Well, I mean, exascale is a kind of hypothetical nirvana out there of programs that can be solved, larger problems that can be solved, and maybe more complex problems. I think to the people programming it, the challenge is is the massive amount of work that's required. Every time I see you in one of these other machines, I say, how can anyone program that? So the one thing that is constant over 30 years is that, and why the prize still needs to exist, is that the difficulty of programming, of utilizing these machines. I think the other thing about not necessarily the size so much, but more the let's call it the scale out. That's the scale up is the size of the machines, but scaling out is really the wider scale adoption of high performance computing into kind of to being more of a standard that other people are using. Then there's that aspect, but then there's now this other thing that's starting to occur, and that was really the movement of a combination or of adoption of data, the data model, data science, whether it's reading all of the medical journals or medical articles so that in fact it can use that to help in diagnosis. Those are the impressive things. That takes a lot of computing, but it's not of the kind that has been the 30 years that I spoke of really were all about simulation. So we've got the scaling up in performance, we've got the scaling out in terms of just large numbers of people using it. And then we've got this other scaling dimension of this adoption of they're being used not so much in simulation, but in analysis and data, and as data science, really trying to understand what we've done. Because as you simulate something, you get so much data out of that, no one can interpret that. So you have to go back to a data model, data science model, data analytics model to say we need computers to actually make that understanding to find the needle in that haystack of data that you've just created.